Hi, in this video, what we're going to do is multiply and divide rational expressions. So, remember that rational expressions are fractions. So everything we've learned about rational expressions apply here as well. And so we multiply and divide our rational expressions, the same as fractions. And I say that fractions as you first learned them. So let's do a review. So a review of a multiplication, and then we'll do a review of division, and then we'll try some rational expressions. So review. And the answer would very simply read, or the problem would read, simplify 4/7 times 21/20. Okay. Now, the key to doing this is to first write the prime factorization of each number. So write, or I've been using the term just factor each number, so we'll just write that, right? I'll write prime factorization this time, right? Prime factorization of each number. Now this is key, and you may have learned that something that felt like a shortcut in an earlier class, but I would encourage you to go back to the basics of what's really happening, because you'll find that if you don't apply the fundamentals, as soon as you get to a rational expression where factors aren't so obvious, you're more likely to be incorrect. So let's try this. So I'm going to just rewrite the problem of 4/7 times 21/20. Now 4 has a prime factorization of 2 times 2. 7, that's a prime number, so there's nothing more to do there. Times 21, that's 7 times 3. 20, that's 4 times 5. 5 is a prime, but 4 is not. But we already said that 4 is 2 times 2. There's the complete prime factorization. And it's once you're at this point that then you can cancel common factors. So let me just write that. All right, now cancel common factors. Okay, so let's do this. We have, I'm going to do this in orange, or we'll do one in each color. So here's a 2, and here's a 2. I'm going to do it this way. So I'm going to cancel this 2 with this 2. Doesn't matter which 2, as long as it's a 2. Here's another 2, and another 2, so we can cancel those. And then if we look around, let's see, we have any more common. Oh, we have another common factor of 7, so let's cancel the 7s. Now we very simply just write exactly what remains. So let's see. What remains is, in the numerator we have a 3, and in the denominator we have a 5. And that's it. Now, the next one is, let's try this. Simplify 15/14 divided by 10/24. Now, here is another good reason for review, if you don't remember. To divide fractions, what we do is we flip the second fraction, and we also do this, and change the division sign, change division to multiplication. That's a multiply sign. Okay, so let's try this. So now we have 15/14. I'll just rewrite the problem, divided by 10/24. So 15 is 5 times 3. 14 breaks down to 2 times 7. Now I'm going to, actually I made a mistake. I should have, let's do this. I ended up combining a couple steps, so let's undo that. Let's do the first thing of just changing the division to multiplication. Times 24 tenths. Okay, now let's factor that. So 15 is 3 times 5. The 14 becomes 2 times 7. Let's see, the 10. 10 is an easier one. 10 is a 2 times 5. And then, let's see, 24 is 8 times 3. Well, 3 is prime, so let's record that. 8, it becomes 2 times 4. Well, the 2 is prime. And then the 4 factors into another 2 times 2. All right, now let's look at what we've got. So let's see. Oh, here we go. Here's a 2 in the denominator and a 2 in the numerator, so I can cancel those. Let's see what else we have. Oh, here's another 2 in the denominator and another 2 in the numerator. And let's see. Oh, 5s. We have a 5 in the numerator here and a 5 in the denominator there. And I think that's it. So now, if we take a look, our remaining numbers, we have a 3 times 2 over a 7, it looks like. So 3 times 3 is 9 times 2. That's 18 sevenths. Okay. So that's how you multiply fractions and divide fractions. Note the key to doing all this is to write the factors. Now, let's look at something more interesting, like a rational expression. And again, the problem is deceptively simple in its presentation. It says, simplify. Simplify. Let's try this one. 6x squared minus 30x plus 36 over 2x squared minus 3x minus 5 times, okay, there's our first fraction, times x squared minus 1 over 4x squared minus 36. Okay, there's a lot to simplify there. So the first thing that we do is, just like we did above, is we need to factor each number. Or in this case, when I say number, I mean, what I really mean is polynomial. Because this, for example, this entire piece, that represents a single number. So let's write that, polynomial. So let's do each one, and then we'll put our pieces back together. So here we go. The first one is 6x squared minus 30x plus 36. Notice that right off the bat, I have a greatest common factor is, looks like we have a 6. So I'm going to take out a 6. That's going to leave me with x squared minus 5x plus 6. Okay. Then you would play the game. And I'm going to leave this to the viewer to verify that I did this correctly. Play the game. And factor by grouping. And when you're done doing that, this should factor into 6 times x minus 3 times x minus 2. Okay, so let's see. The next part we have, let's factor the 2x squared minus 3x minus 5. I find these ones a little harder, so I'm going to help myself out here. Remember, in the top spot, I know I'm going kind of quick, but we've been practicing this now a good bit. So I put in the numerator the 2 times minus 5, so that's a minus 10. And then in the bottom position, I put the minus 3. And it looks like if I have a minus 5 and a positive 2, that I can unlock this polynomial, this quadratic, actually. So I take 2x squared minus 5x plus 2x minus 5. And I have a common factor of x in my first group. And in the second group, I've already got a 2x minus 5, but you need something so that you can take out the greatest common factor, or create a greatest common factor, excuse me. So this becomes plus 1 times 2x minus 5. And now I've created a greatest common factor of 2x minus 5, x plus 1. Okay. The next one, I'll look at the next one, x squared minus 1 up above. X squared minus 1. Notice that we have a squared term in the x squared, the minus here, and that you can take 1 and write it as 1 squared. This becomes a difference of squares. And if you didn't see that, that's all right. You would play the game with a 0x in the middle. So difference of QUA, difference of squares. And so we know that fits the pattern of x plus 1 times x minus 1. Okay, our last piece is 4x squared minus 36. Factor out of 4. That's going to leave an x squared minus 9. Oh, and if you look at this, x squared minus 9, that's also a difference of squares. If you think of it this way, if you think of it as 4 times x squared minus 3 squared. There. Now we can take this as 4 times x plus 3, x minus 3. Now, wow, that's a lot of factoring, but that's what's required. So let's put all of this back together. So here we go. My first one factored, this is going to get a lot of moving. I'm going to even go so far as to factor 6 into 2 times 3. Here we go. So now, I'm going to rewrite the problem so you can see this. So the problem began as 6x squared minus 30x plus 36 over 2x squared minus 3x minus 5 times x squared minus 1 over 4x squared minus 36. Okay, now we factored each one of these. The first one, the 6x squared polynomial, factored into 6 times, and we said 6 is 2 times 3. And if we look up above, what did we have? We had x minus 3, x minus 2. Over, then the next one we can see on the screen above comes from 2x minus 5, x plus 1 times the x squared minus 1 was a difference of squares, so it became x plus 1, x minus 1, and then the 4x squared one becomes 4 times, but 4, remember, that's 2 times 2, times x plus 3, x minus 3, and now we can cancel. Let's see, oh, here we go. I have a 2 in the numerator here and a 2 in the denominator. Then, let's see, what else can we cancel? If I look at it, maybe, oh, look, here's an x minus 3 in the numerator and an x minus 3 in the denominator. And oh, there's one more holding out for us. This one is an x plus 1 and an x plus 1. Okay, I think we're ready to reassemble what we have. So this might feel a little different. I'm going to move my equals to the left for space here. If I rewrite exactly what remains, I have a 3, an x minus 2, x minus 1. And in the denominator, I'm going to put my 2 first. So I have a 2, then I have a 2x minus 5, and finally an x plus 3. Now this is an acceptable answer. I'll write it this way: acceptable answer in factored form. And more often than not, we usually leave our answers in factored form, but sometimes we don't. So what we could do is, and this would be a good review, so I'm going to do it, is we could put this back into its full polynomial form. So remember, what we have to do is we have to distribute. So I'm going to use some arrows here. So I first take the x times the x, and I get, so I'm going to go, we'll deal with the 3 in a moment. So x times x, and I get x squared. Then I take this x and I multiply it by the minus 1 to get a minus 1x. Then we do the same thing now, and we do this with the minus 2. So I go minus 2 times x to get a minus 2x. Minus 2 times a minus 1 to get a plus 2. Okay, that's my new numerator. We'll clean it up in the next step. And then in the denominator, I'm going to have 2 times. And let's do this again here. We have a 2x times an x, so that's going to be 2x squared. I have a 2x times a 3 to get a plus 6x. Okay, then I have a negative 5 times x for a minus 5x. And then a minus 5 times 3 for a minus 15. Now, if I clean this up, I have, and we'll do this in a couple pieces, I have 3 times. The numerator becomes x squared, and then I combine these because I have a minus 1x minus 2 more x's for a minus 3x plus 2. Over, in the denominator, I'm going to have 2 times 2x squared, and then I have a 6x minus a 5x right there. That just leaves me with a plus 1x, or plus x, minus 15. My final step is to distribute the 3 through the numerator and the 2 through the denominator to get 3x squared minus 9x plus 6 over 4x squared plus 2x minus 30. And this is an acceptable answer in, call it polynomial form. Okay. Let's try, I know this is getting a little long, but we're going to try it one more. And again, it reads the same. Simplify. And what we're going to do is we are going to simplify x squared minus 1 over x cubed plus 1. And we're going to divide that by 2x minus 2 over x squared minus x plus 1. Okay, so that's the problem. And here's what we would do. I'm going to start by rewriting it again. I know maybe you're doing the same thing as you watch this. And you may speed up your steps, but I usually find that the faster I go through the steps, the more mistakes I tend to make. So let's just practice them. X squared minus 1, x cubed plus 1. And the first thing we want to do is change the division to multiplication. And we flip the second fraction, which is also called the reciprocal. X squared minus x plus 1 over 2x minus 2. So now let's go back and remember that the process now is factor each polynomial. Now, I'm going to this time go a little faster. You might want to practice this, but let's label these, because this first one right here fits a pattern. It's a difference of squares. And we actually saw that one above. Okay, then this down here, this fits the pattern of sum of cubes. Okay, this one, the x squared minus x plus 1, it actually doesn't factor. You could try with the game, but what you find is you can't find any answers. And when that happens, that you can't factor it, we call it prime. So there's nothing to do. This last one, 2x minus 2, it's very simple. All you have to do is take out the greatest common factor, which is 2. So I'm going to now rewrite the problem factored. So equals, the first I have an x plus 1, the difference of squares, times x minus 1. The sum of cubes factors into, let's see, we use the x, and then we use the same sign. Remember, SOAP, same sign. So plus 1. Then we have an x squared. Then we use the opposite sign. So that's going to be a minus 1x. And then plus, it's always positive, plus 1 squared, which is just 1. Times, then we have an x squared minus x plus 1. Over, and then I factor my 2, and I'm left with an x minus 1. So let's see if we have any common factors that we can cancel here. It looks like, oh, right off the bat, there's an x plus 1 in the numerator, and right below it is another x plus 1. Okay, let's see if there's any more. Any more for magenta. Oh, here's an x minus 1. And here's an x minus 1 in the denominator of the second fraction. And even better, look at this. This x squared minus 1x plus 1 is the same as this x squared minus x plus 1. You might want to think of all of that as in parentheses. Now, notice that everything has been canceled from the numerator. You have to remember there's always, in multiplication, there's always a 1 that can be left behind. So, there we go. Our final answer is, if we write what remains, I have a 1 in the numerator and a 2 in the denominator for a final answer of 1/2. Thanks for watching.